Hey, today's lesson is going to be about something called absolute value inequalities. So you should have your composition notebook out. I want you to write down the title. Now, we've talked about absolute value before in this class, and we've talked about inequalities before, but today we're going to mix the two. So as soon as everyone's ready with their title written down, let's get started. 3 examples today. First, I want to talk about the weather. Oh, it's been cold lately. You know what would be perfect? 72 degrees. In fact, let's say 72 degrees Fahrenheit is the perfect weather. That's ideal. Sun is shining. Not too cold, not too hot. It's perfect. And, there's a range around 72 that's not too bad either. In fact, let's say that any temperature within 8 degrees of 72 is nice. And so what we're going to do right now is build an absolute value inequality for this nice weather. And here's how we're going to do it. Start by talking about some random temperature, T. If you wanted to know how far away your temperature is from 72, you would subtract it. But here's the thing. When we're talking about how far away from 72, we're really talking about the distance. From 72 degrees. And so we don't care about whether it's positive or negative. We fix this by putting those absolute value bars on it. So this expression here now says the distance of a temperature from 72. Now, we say that it's nice as long as that distance is smaller. There's the inequality, than 8 degrees. So if the distance is less than 8 degrees, we'll say less than or equal to, then we have a nice temperature. So here's our first absolute value inequality. We're going to talk about how to solve it now, and it is a 4-step process. Step 1 is you're going to split the inequality into 2 pieces, a negative and a positive piece. We're going to, for the time being, kind of ignore the fact that there's that inequality symbol. It'll come back in a moment. And so let's treat this just like we do absolute value equations and say that t minus 72, because of the absolute value, it could be negative 8, or that t minus 72, it could be positive 8. And so step 2, we're going to take this equation and this equation, and we're going to solve them separately. So first one, add 72 degrees on. We get that the temperature could be, 66 degrees. So that's like the smallest temperature that would be nice. And then right here, let's add 72 to both sides. We get temperature equals 8 plus 72 is 80 degrees. So that's the largest temperature that would be nice. Step 3 is we're going to graph the set of possible solutions to this inequality up here. And so let's start with 66 right here, 80 degrees right here. 66 is a perfectly good temperature, it's included. 80 is a perfectly good temperature, it's included. And then we know that our temperatures will be in between. So we want the values right there. Now, if you didn't know that they were going to be in between, like we kind of did because of the temperature, you could do a quick test. You could pick a number between 66 and 80. So, let's for instance take 70. 70 is in between there. And I'm going to do a little test with 70. And what I mean by test is I'm going to plug it into the inequality. So the inequality was temperature minus 72. And so if we plug that in, we get absolute value of 70 minus 72 is negative 2. Absolute value of negative 2 is 2. Now, is that less than or equal to 8? Yes. Okay. And so that tells us that our solutions are in the middle. We have an intersection. So last step, step 4, is write our answer. So we have an intersection. We know how intersections are set up. We say x, or actually scratch that x because we're talking about T here. Temperature is less than or equal to 80 and is greater than or equal to 66 degrees. There's your answer to the first question. Let's do 2 more of these to practice. Example 2. This time, let's suppose we want to solve the inequality absolute value of 9 minus 4x is greater than 17. So the first thing that we're going to do here is we're going to break it into the 2 parts. And so the first part says 9 minus 4x could be negative 17. Second part says 9 minus 4x could be 17. And you're going to take both of those equations and you're going to solve them. So let's start with the first one. Subtract 9 from both sides. We get negative 4 times x is equal to negative 26. And then divide both sides by negative 4. We get x could be equal to 6.5. Over here, subtract 9 from both sides. We get negative 4 times x could be 8. Divide both sides by negative 4. You get x is equal to negative 2. So again, we've got our important points. What we need to do with those important points is graph them. So I'm going to put the negative 2 over here because it's smaller, and the 6.5 over here because it's bigger. And this time we know that our important points are going to be excluded. They're not going to be included in the answer because there's no or equal to on our equation. So now I'm going to test a value in the middle, and I notice that 0 is a number in the middle, and that's pretty easy to test. So I'm going to take 0, and I'm going to plug it into this equation right here. And let's see what happens when we do that. We get absolute value of 9 minus 4 times 0 is equal to the absolute value of 9, which is equal to 9. Now the other side of the inequality says is greater than 17. In this case, 9 is not greater than 17. That means that our solutions are not in the middle where we tested. If our solutions are not in the middle, that means that our solutions are going to be on the ends. So we get above and below. You can test. If you pick a value like 7 or 8 or 9, it'll work. And if you pick a value like negative 3 or negative 4 or negative 5, it'll work too. Because this one is a union. And so the last step, now that we've got our picture, is to write the solutions as x is less than negative 2 or x is greater than 6.5. One last example. Absolute value of 3x minus 14 is less than 8. Now what I want you to do is try the first step on your own. Pause the video here. Okay. For the first step, did you get 3x minus 14 is equal to negative 8, or 3x minus 14 is equal to 8? And then if you simplify those equations, this one you end up with x is equal to 2, and this one you end up with x is equal to 7.333333, which we will put a repeten symbol over the 3. Okay. Try the next step now where you draw the graph. Okay, did you get this? 2 here, 7.3 here. Circle it, circle it. Trickiest part is figuring out where to shade. What I like to do is pick a number in the middle and test it. So between 2 and 7.3 is, say, 5. 5 is in there. So let's do absolute value of 3 times 5 minus 14. Which is going to give us absolute value of 15 minus 14, which is equal to 1. 1 is less than 8, so our solutions are in the middle. This one's going to be an intersection. You don't want to leave it right there. You want to make sure that you remember your final step, which is to state this intersection, which will be x is less than 7.3, repeating, but it is bigger than 2. There's your answer. Okay. So that's it for today's lesson. You have an assignment to complete in class, and then you have a home fun assignment, which is on your assignment sheet.